Okay, so we are continuing our discussions on conditional statements. Of course, we had started looking at some of these converse, inverse, contrapositive. We had also looked at, I believe, an example last time. I think it was example 4 that we had looked at last time, if I am not mistaken. Because I know we had done one of these where we were just rewriting it into symbols, and then we had done number 4 where we talked about how to write that. Do you remember if we had finished that example or if we needed to finish that example? As far as I remember we had finished talking about it, and we had actually defined what each of those statements would end up looking like when you did the converse, inverse, contrapositive, and then talk about the equivalent statements. All right, so let's talk about the equivalent conditional statements over here. So, when we're looking at the equivalent conditional statements, of course, we're talking about, in terms of your conditional statement being, the original P implies Q. Then you have your converse, which is, Q implies P. So you're switching the places of the consequent and the antecedent. We've got the inverse, where we take a negation on both P and Q statements. And contrapositive is a negation, but then we're also interchanging our antecedent and consequent. So we're talking about, which ones of these would convey the same meaning, which means which one of these would be equivalent. So just looking at an example over here, we're actually using the truth table to try and see, which ones would have the same truth value. So you can see we're starting with our P and Q statements. We've got the negations on both of them, and now we're going to try and complete each one of these conditional statements. So if you look at the completed example over here, we've got our P implies Q, so that's going from true, false, true, and true, and you can see that is going to be equivalent to your contrapositive. So the conditional goes with contrapositive, and we had kind of talked about this last time also, and then the Q implies P, which is the converse, goes with the inverse, and they are going to be equivalent to each other. And you can kind of see, we're talking about those right over here, which two statements are going to be equivalent. So you will definitely see some examples, where we are talking about these equivalency. You've got, of course, the table over here. So I actually wanted to take an example here from our textbook. And this one again is kind of doing the same thing. They are saying, we're looking at example 6 over here. So basically they're saying to create the inverse, the converse, and the contrapositive for our given conditional statement over here. And again, we'll talk about the equivalent statement. So looking at number 6, we've got, if you have the necessary tools, assembly time is less than 30 minutes. So if this is the original conditional statement, what do you think the inverse for the statement is going to look like? And again, you can use your notes to identify, again, what those inverse, converse, and contrapositive statements will end up looking like by looking at this table over here. So using this example, number 6, what do you think our inverse statement for this will end up looking like? Because, first you have to identify what those individual P and Q statements will be. So if you had to define your statement P, what would you say it will be? Okay, let me see what you have. You have the necessary tools. Okay, so are you defining that burgundy as your P statement, the antecedent? Okay. Oops. Wrong page. Okay. All right, so burgundy, you are saying you have the necessary tools is going to be our P statement, okay? What are we going to do for the Q?
The assembly takes 30 minutes.
Okay. Less than, right? Assembly time, oops, is less than 30 minutes. Okay, so now can you tell me what our inverse will end up looking like? So remember, your conditional is given to us as E implies Q. Inverse, and again, like I said, you can use your class notes over here. You will see the inverse is going to be where we take a negation on both our antecedent and consequent. So using that, what will the inverse for this example look like? Okay, Aaron, you've got if the assembly line is not less than 30 minutes, then you do not have the necessary tools. If the assembly, you do not have necessary tools, then the assembly line will not be less than 30 minutes. Okay, so Isabel and Lisbeth, you guys have the correct answer because we are talking about keeping the order the same. So it's still P implies Q, but you are taking negation. So Becca and Aaron, what you guys did was you actually ended up switching your P and Q statements. Do you see that?
I I thought the inverse was you switch them.
Oh, that's the contrapositive where you switch and do the negation. So
Okay,
inverse is where you are just taking a negation in the same order.
okay, so inverse is still the P, then Q. They're
Right.
just negations.
But now you're doing a negation. Exactly.
Okay,
All right. So yeah, so you guys had, if you do not have the necessary tools, then the assembly time is not less than 30 minutes. So just making a negation on both of them. All right, then our next one was asking for the converse. And let me clear this out. So again, remember the converse is going to be where there's no negation, but for the converse, this is where you change the order of your antecedent and consequent. So again, what will this guy come out to be then? Okay, so let me see, Isabel, Lisbeth, you have if the assembly line is less than 30 minutes, then you have the necessary tools. Yeah, very nice. So again, just changing the order of your P and Q statements. So instead of that, we will do if assembly time is less than 30 minutes. So that's going to become our first part. then you have the necessary tools. Okay, and so that brings us to the very last one, which is the contrapositive. And remember, contrapositive is where, as I was just showing you guys, you actually are using the converse, but now you are doing negations on each of those statements. So basically, you just take what we did here in the converse and you make negations on those two statements. So that's going to be, and this is something, as I was mentioning last time also, you will need to remember when you do your quizzes and especially your exam, because if you mess up with any of those orders, then obviously you would be getting the incorrect answer. So I'm seeing your answers coming through on the chat. So yeah, if the assembly time is not less than 30 minutes, then you do not have the necessary tools. So just negating those statements. Now, again, when we talk about equivalency, remember we said that the conditional is equivalent to the contrapositive, and the converse is equivalent to the inverse. So basically, in our example, that means our original statement, P implies Q, would have the same meaning as the contrapositive, Q implies P, and then our inverse and converse would have the same meaning. They would be the equivalent statements. So kind of keep those equivalency groupings in mind, as you are going through these examples also. So just couple different examples to show you how, these variations on our conditional statements end up looking like. Okay, so let's look at another connective. So far we have looked at the and as a connective, we have looked at or, and of course we've done the if-then connective also. Now we are looking at the only if connective over here. So as you can see, we're talking about the statement, a prisoner is paroled only if the prisoner obeys the rules. So they want to know in this case, what would be our antecedent, what would be the consequent, rather than using P and Q, which might bias our investigation. They're talking about just changing those letters from P and Q to R and S. Just, bringing in new letters over here. A prisoner is paroled is for the R. A prisoner obeys the rules is the S. So in this case, if you look at the way the statement was written out in words, we are saying, we can represent it as R only if S. We can, write it in that form. Now, when it comes to writing it in different ways, they're talking about, R only if S means that R can happen, only if the second part or the S part happens, which is, if the prisoner would obey rules, then the prisoner would be paroled. So they are saying what happens if S does not happen. So, if the prisoner does not obey the rules. So, of course, that means if they are not obeying the rule, then they would not be paroled. So that means you would have the symbolic form saying not S implies not R, which is going to be equivalent to R implies S, because they're going back to our equivalency over here, because we know when we do the negations and we also switch the order of our P and Q values, it is equivalent to the original P implies Q. So they're actually using that same idea over here, where not R implies not S implies not R is going to be equivalent to R implies S. So we're still using that same original equivalency, but instead of using P and Q, we're using R and S as our statement definitions over here. So that means when we are talking about R only if S, our prisoner example over here is actually going to be equivalent to R implies S. So what they're talking about, another way of writing our conditional statements P implies Q, instead of using the if-then statement, you can actually also use only if as our connective word also, and that still ends up giving us the same original conditional symbolism. So they're basically saying that when you are using the if-then statement, that can actually be equivalent to the P only if Q statements also. So that's kind of what this example here is highlighting for us. So they're saying we have a compound statement. You receive a federal grant only if your artwork is not obscene. So they want to, help us find the antecedent, consequent, write this in the if-then format, and then they're talking about interpret the conditions that would make the statement false. So you can see we are talking about this as an only if statement. So in this case, your antecedent would become the federal grant. So that's going to be our antecedent. Our consequent is actually again going to be the second half, which is your artwork is not obscene. So you can see this is very similar to what we did in the if-then statement. The first part becomes your antecedent, and the second part will become the consequent. Now, when you're trying to rewrite this in the if-then format, it's going to be pretty much the same thing. Our antecedent is if you receive a federal grant, then your artwork is not obscene. So you will see that order of the antecedent and the consequent stays the same from only if to if then. So keep in mind, they are equivalent statements over here. Now they were talking about, in under what conditions the statement could be false. So again, using our P and Q statements, we can go ahead and create this table, and you will see the only time this statement is false in that first case where P is true and Q is true. So they're basically saying if you receive the federal grant, even if your artwork was obscene, that's where this statement would be a false statement, because technically they are saying if the artwork is obscene, you should not be getting a federal grant. But if you're getting a federal grant and your artwork is obscene, that means you didn't meet the condition, right? You didn't meet the condition, but you still ended up getting that money. So that means your claim of that statement was going to be false. So that's kind of what they want to know when they're saying under what conditions the statement would be false. And you can kind of see that over here in this description over here. So just keep in mind your only if is equivalent to the if then statement. Okay. So that was one connective we hadn't talked about. Now this is another type of statement that we haven't looked at just yet, and this is what we call as biconditional. So if you think of the conditional statement, conditional statements are always going in one direction. Either P implies Q or Q implies P. So with biconditional, it actually means you're going both ways. So it's going to be P implies Q and it's going to be Q implies P. So it actually goes in both directions, and that's why you will see that arrow has, it's a two-headed arrow because it goes in both directions. So they're kind of talking about, when you look at the words like bicycle, binomial, bilingual, we're basically talking about, bi having that prefix of two. So you're talking about, basically having two wheels on your bicycle. Binomial means you have two terms. Bilingual means you can speak two languages. So obviously biconditional will mean you have two conditions in here. So they're talking about, just these examples that you can look at over here. We're saying, if I am rich, then I am happy. And if I am happy, then I am rich. So you can see how this conditional is going both ways. If you are rich, it makes you happy. If you're happy, then you must be rich, kind of, an idea over here. So basically they are saying we're using conditionals over here. We have the if then format on both of these conditions, and we are using the word and to join them together. So symbolically, this is kind of what this statement here would end up looking like. But, instead of writing it with two conditions and using that and, it's actually a lot simpler to just write it P double implication Q, because again, you're going in both directions. And then they're kind of talking about, obviously, if you were to write the whole thing out, they would still be equivalent. And, it's as easy as doing a truth table to try and verify that those two statements would, in fact, be equivalent to each other. So this symbol that you have for the biconditional, you can read it as P, if and only if Q. And sometimes we abbreviate that if and only if with if, but with two F's. So the IFF is basically talking about if and only if. Okay, so that's kind of how we write these biconditional down. And then, with the conditional statements, if you remember, we had also discussed how in words you can write these, P is necessary for Q or Q is necessary for P. So we can use those same terminologies of sufficient and necessary with the biconditional statements over here. And in a biconditional statement, you actually end up writing it in this format where you use both the words in your sentence. So you would say P is necessary and sufficient for Q. So that's kind of how, we would bring those conditionals going in one direction. We want to bring it for both directions. And so we end up using, both of those terminologies here with our biconditional statements. So just as an example here, they're talking about express the biconditional. A citizen is eligible to vote if and only if the citizen is at least 18 years old. So guys, this is what you will be looking for, whenever we are looking for biconditionals. You have to have either the if and only if connecting word, or you should have this is necessary and sufficient for, if you're looking at biconditional statements. So they want to know if we can rewrite this as a conjunction of two conditionals. Now remember, conjunction of two conditionals is this part we're talking about, where you're using the and symbol, and then you are using the conditional, the single arrow, but going in both, Q implies P and P implies Q direction. So you will see how they are trying to do this here in our truth table over here. We start with our two columns for P and Q. Then we are doing each individual direction. P implies Q and Q implies P. And then when you use the and symbol between these two columns, this will actually end up giving you what that final column for the biconditional statement would end up looking like. So if you look at these, when both my P and Q are individually true, we have a truth value for the biconditional. When both of our P and Q truth values are false, we also have a truth on our biconditional. But if they are, one is true and the other one is false, then that means you're going to have a false value in your biconditional statement. So it's a little bit different than our, if then statement that we had looked at in the previous section over here. So I wanted to pick a couple examples for us to work through just to make sure you will be comfortable with these biconditional statements over here and the if only if statement also. So let's look at number 16 over here.
I had a question real quick.
Yeah, sure.
So for number 4 on the truth table that you just showed us for the biconditional truth table, the fourth one for P and Q said they were both false, but for the end part at the very end of it, it says it's true. How does that work exactly?
Okay, yeah, that's a good question. So let's take a look at this idea of, if I am rich, I am happy, and if I am happy, I am rich. So that tells us that, if both of them are false, so think about it this way. If both of them are false, then we are saying I am not rich and I am not happy, right? Because if we are taking the original statement to be true, that I am rich, and true for I am happy. So when we say they are both false, which means I am not rich, then I am not happy. We're basically saying, if you think about the statement itself, where I am saying I am happy if and only if I am rich. So if you're not rich, you're not happy, are you making a false claim? So think about this again. If your biconditional statement is I am happy if and only if I am rich. So we're saying both of them are false. You are not happy and you are not rich. Or, anybody is not happy and they're not rich. So are we making a false claim when we say, I am happy if and only if I am rich? Because if both individual statements are false, is our claim false? Because our claim is, I am rich if and only if I am happy. And remember, this goes in both directions. So I can also rewrite the same statement as I am rich if and only if I am happy. So would we be making a false claim if we were not rich and let's say we're not happy? Or in this example that we had over here, where they were talking about a citizen is eligible to vote if and only if they are 18 years old. So think about it in those terms. So if you are not 18 years old and you don't get to vote, so did we make a false claim in that case when we are saying a citizen can vote if and only if they are 18 years old? So if the person is not 18, they don't get to vote, did we actually make a false claim, or is our claim still true?
The claim is still true?
Yeah, because obviously we're not meeting either of those conditions, right? We are not 18, and obviously we don't get to vote. So our claim, when we say we are, if you are 18 years old, if and only if you get to vote, well, since we didn't meet those requirements, our claim is not false. So that's why, Aaron, both those statements can be false, but your claim can still be true. But think about the other two cases in the middle. So let's say we are saying you get to vote, but you were not 18 years old. So our statement that a citizen gets to vote if and only if they are 18 years old would be false, right? Because they were not 18, but they still got to vote. Okay. So that claim is incorrect, right?
Yeah.
Okay, and then think about the third case where we are saying a citizen cannot vote, but they are 18 years old. So if your claim is you can vote if and only if you are 18 years old, but then this person does not get to vote, even though they are meeting the age requirement. So again, would that claim be false?
Yeah, it would be false because you're saying that this person cannot vote even though they are 18.
There you go. Yeah, exactly. So what we are thinking is, in terms of the claim, is that true or not? Now, of course, in the first case where the person can vote and they are 18, we have no problem. We know it's going to be true. But yeah, that where both of them are false, it can always seem like, why is that still true? Because our brain is telling us, well, shouldn't that be false since both our statements are false? But in this case, your claim will still be true, because we are still saying that you did not meet our condition, so you didn't get the result that you were hoping for. So that is still going to stay true even when both individual statements are false.
Okay, thank you.
Yeah, you're welcome. Did anybody else have a question on that? All right, so let's take a look at that example number 16 over here. So in this case, you can see they are asking us to again find our antecedent consequent, to rewrite this in the if-then form. And then of course, let's try and find out where this statement might be false. Excuse me. So they're telling us, I eat raw fish only if I am in a Japanese restaurant. So what would you define as your P and Q statements for this one? So what would you define as the P and the Q statement in here? I eat raw fish only if I am in a Japanese restaurant. Yeah, very nice, Isabel Burgundy. Okay. And your Q statement?
I think the Q statement is I'm in a Japanese restaurant.
Yeah, very nice. And Burgundy, Isabel, you guys have that too. All right, very nice. Alrighty, so which one is P the antecedent or is Q the antecedent? Q is the antecedent, so that would be the first part of our P and Q statement. Okay, Aaron, you're going with P. Ethan, P. Yeah, remember guys, the P implies, if this will let me write, P implies Q, remember, can be written as if P, then Q. But it can also be written as, and you know, we just talked about this in our 1.4, P only if Q. So it can have these two formats. So Burgundy, that first part is still going to be your antecedent in this case. So it would actually still be I eat raw fish as the antecedent. Does that make sense? You look like you're not convinced. Okay, okay. So of course, then I am at a Japanese restaurant would become our consequent. Now, how will you write this in the if-then format? What would that look like in words when you write out the if-then? Very nice. Yeah, Isabella, very nice. Okay, so let's see. You have if I eat raw fish. Oops. Ethan, if I eat raw fish, then I am at a Japanese restaurant. Very nice. So we need to get rid of that, you know, only if, and you're just saying, if I eat raw fish, then I am in a Japanese restaurant. Alrighty, very nice. And I think the last part was asking us, you know, where can we show if we have a false statement in this case. So of course, then we need to go ahead and create our table over here. Okay, so let's see. We would have our P, Q, and then let's see. Do we have any negations in here that we need to carry on with? No negations, right? Because it's saying I eat raw fish, I am at a Japanese restaurant. So you actually don't have any negations in this example. So we can just do P implies Q directly. So what do you think, under which circumstance do you think we would have a false condition over here in our P implies Q statement? Do we remember when P implies Q is false, under what conditions? And you may have to go back to 1.3 to get your table. So that's your truth table for P implies Q from 1.3. So you can see the only time a conditional statement fails is when the first part is true, but the second part is false, right? So think about that in our example over here. So that would be true, false, and then true and true for these guys. So this is the only instance, when this statement is going to be false. So that actually means you are eating raw fish, but you are not at a Japanese restaurant, right? So that's when this claim would end up being false. So basically, this is what we would have to say in our conclusion over here. Okay, Isabel, you actually said only when the consequent is true, but it's actually the other way. The antecedent would be true, but the consequent would be false. So we would say, oops. Okay, so we would say the statement is false. It's false when, we are eating, or I guess this is when I eat raw fish, but I am not at a Japanese restaurant. Okay, so only under this condition, our statement would be false. Okay, so Aaron, you want to know how is P implies Q in the second row false? So think about it again, like I said, we are talking about making a claim. If I eat raw fish, then I am in a Japanese restaurant, right? So our first part is saying, if you're eating raw fish, then you have to be at a Japanese restaurant, which means we're saying you cannot be anywhere else, right? So what's happening in that second condition where we're saying, yes, we are eating raw fish, which is true, but we are not at a Japanese restaurant. So then your claim of if I eat raw fish, then I'm in a Japanese restaurant is going to be false, because technically you're still eating the raw fish, but physically you're not at a Japanese restaurant. Maybe you're at home, or maybe, at some other establishment. So that's why that second condition is going to be false. If you actually remember, the example we had done in our handout was, if you pay me $50, I give you tickets to an opera or something like that. So the idea is, if you think about it, you gave me the $50, which means the first part is met. That's true. I got the money from you, but then I don't give you the tickets to this show. So then I didn't meet my end of the bargain, right? You gave me the money, but you did not get the tickets in return. So the claim, when I made the claim saying, if you give me money, I will give you tickets. Well, I am basically lying. I'm not making a true statement over here, because you gave me the money, but then you didn't get your tickets in return. So that's the same thing happening over here. You're eating raw fish, but you're not at a Japanese restaurant. So if you tell somebody, if I'm eating raw fish, I'm at a Japanese restaurant, that means that claim is false, because you can obviously be eating raw fish at different places. So do you see why that statement turns into a false statement? Yeah? All right, wonderful. Very nice. All righty, guys, good job. Now let's take a look at another example over here. Let me see. Okay. All right, let's look at number 42 over here. So your instructions for number 42 are basically write an equivalent variation of the given conditional statement over here. So these are the instructions. And we are looking at example number 42. So you are not an artist if you are not creative. So how would you write the equivalent statement for this? So I would say first go ahead and write down in P and Q form what each individual statement would look like, and then you would have to recognize, is this in the straightforward conditional format? Is this converse, inverse, contrapositive? Because then you would have to decide what your equivalent statement would be. So why don't you start by identifying the P and the Q statement in this example first? Okay, so I'd like to see some answers coming from someone who hasn't answered yet. Okay, let me see. Okay, so most of you are going with P as you are an artist, okay? And so that means we are going with Q as you are creative, okay? Okay, so can you recognize what format is this original statement in? Is it a conditional, converse, inverse, or contrapositive? Because, you know, of course, we are defining you are an artist. So that's the first part. If you are not creative, you can give it to me symbolically if that's going to be easier for you to start out with. Ethan, you're going with contrapositive. Because if you see, we are defining P as you are an artist. Of course, this guy here is not P because we are saying you are not an artist. Then you've got your if over here. And then we are saying you are not creative. So again, that's a negation on you are not creative. Okay, Aaron, you're saying it's a converse statement. Okay, now, Markley, you've got not P implies not Q. All right, so let's think about this one more time, guys. This is if you are not creative. Remember, if is always going to be the antecedent part. So that means this is actually a statement in the form of not Q because that's coming with the if you are not creative part. So the implication or the consequent is actually going to be you are not an artist. Okay, so Aaron, you're calling this a conditional statement. So it actually wouldn't be conditional for the simple reason that we do have our negations in there. So if you again just go back quickly and look at your for 1.4 handout. Now, kind of going to that first page. So you can see we are actually in the format of not Q implies not P. And so I think it was Ethan that you had in there as contrapositive. So yeah, this is actually going to be our contrapositive statement. So now when we talk about equivalency, what is equivalent to the contrapositive? Converse, inverse, or the conditional statement itself? Okay, so Burgundy, you're saying realistically this problem have two answers. Yes, Burgundy, so you could actually, depending on how you define your P and Q statements, you could have this in a different format. Okay, so again, think about this. What is equivalent with our contrapositive statement over here? And let's look at this. Contrapositive is equivalent with the conditional. So not the inverse. The inverse goes with the converse. The conditional goes with the contrapositive. So you would actually be rewriting this in the format. So for its equivalent statement, we would have not Q implies not P is actually equivalent to P implies Q. So in words, what would our P implies Q look like? Oh, Kiara, so it's got to be if P then Q. So it should actually be if on the P portion, and you've got if on the creative on the Q portion. So in this case, you can see how originally we have not Q implies not P as the statement that was given to us in the example. So that means for equivalency, you're actually going to be taking the P statement and putting that down first. So P in this case, as you can see, the way we defined it, we are defining you are an artist as our P statement over here. So that's what you are actually going to have for the conditional statement, and that's going to be our first part. So if you are an artist is going to be our antecedent, and then our consequent, of course, would be you are creative. Does that make sense? So as you can see, this example really highlights a bunch of different things you are going to have to be careful about when you go through these examples. First, you have to define what your P and Q statements are going to be. Based on how you define P and Q, that order of the first statement is going to be based on, you know, what you come up with. So if you had the way we have this here in, you know, what you're seeing on your screen, then that means our original statement was actually defined as not Q implies not P. Now keep in mind, as I have this highlighted in green over here, the if portion is always going to be your antecedent. So that's always going to be the first part. And then the second portion is your consequence. So that's what's going to go in the second place. So just by looking at the order, you can see we have it not Q implies not P, which is our contrapositive statement. And then as I showed you over here, contrapositive is always going to be equivalent to the conditional statement. So it always has to be in this order of P implies Q is equivalent to not Q implies not P. So using that idea, we knew we had to come up with P implies Q. So you can see with the if part, we have P, so that's our consequent. And then with the then part, which is our consequent, you have the you are creative, which is the Q part. So this is in the format P implies Q. So remember, with the if, you always have the antecedent, which is the first part. With the then, you always have the consequent. And remember, we don't have to actually have the word then in there. You can skip then like you have in that example for 42. You have to have the if portion in there because that identifies the antecedent, but you don't have to physically have the word then to show that you are talking about the consequent. Okay. All right, so just some examples on, you know, your section 1.4. Now, the last section that we wanted to look at, because I think we talked about, yeah, just the different examples we have in here. Now, in section 1.5, we are actually talking about just, you know, making sure we are able to understand what these statements are talking about, kind of bringing everything we have looked at in chapter 1 and, kind of putting it all together over here. So they're talking about, again, kind of using that example of Alice in Wonderland and how the author used logic in that. So they're saying Lewis Carroll's Cheshire Cat told Alice that he was mad, crazy. Then Alice asks him, how do you know that you're mad? And he's saying, to begin with, a dog's not mad. You grant that, I suppose so, she says. So he's saying, you see a dog growls when it's angry, wags its tail when it's pleased. Now I growl when I'm pleased and wag my tail when I'm angry. So he's saying, obviously he's doing it in the opposite way. That's what makes him mad. So the idea here is, this may again seem gibberish, but don't again think in terms of English, things in terms of logic. So they want to know, well, does he have a valid deductive argument? We want to know, does the conclusion, follow logically from the different premises we have seen about, logic in this case. So again, we can, basically break this down into symbolic logic. We can use truth tables to try and see the argument that Cheshire is making about, I growl when I'm pleased and wag my tail when I'm angry. So can we say the claim that he's making is actually going to be valid or not? So when we're talking about valid arguments, remember we did that in the first section of 1.1 where we talked about, looking at the validity. We use those Venn diagrams to kind of try and see, where we could place the X for our statement and kind of use that to try and see if we had a valid argument or not. So we're kind of bringing that same idea over here, but we're actually going to be using truth tables to help us out with the validity instead of just looking at it in terms of, Venn diagrams and, stuff like that. So again, just to bring forth definitions over here, we're talking about an argument that consists two components. You have the initial statements or the premises, and then of course we have the final statement or the conclusion. So this is kind of what we would call an argument. All men are mortal. Socrates is a man. We would say these are the premises. And remember, you had the major premise and the minor premise, and then you have your conclusion. Therefore, Socrates is mortal. So this is what we would call as an argument. Now, when we are saying if the argument is valid or not, for an argument to be valid, remember we said that your conclusion has to be guaranteed under every given circumstance. So we're saying the conclusion of the argument is guaranteed under its given set of premises, which means every time we should be able to reach that same conclusion. We should be able to get that same result. And that's what would make our argument valid. So basically they are saying your conclusion should be inescapable in all cases, in all instances. So that's kind of what we had done in that, first section over here. Remember, we had also looked at this example about all doctors are men. My mother is a doctor, so therefore my mother is a man. Now, I know logically this is a sound argument. This is a good argument, but we know in reality it wouldn't be true because a mother would not be a man. But, as far as our argument, the way it's set up goes, this conclusion is actually guaranteed. So we would say logically, this is correct, this is valid. And so that's kind of how logic may not make sense in English, but logically, if we are able to say, yes, this conclusion is something we are going to get every single time, then we can say that's a valid argument. So here, and you can kind of see some of this minor description. Again, I would recommend you guys to kind of read through your handouts, but we're talking about, the conditional representation of an argument. They're kind of using P sub 1, P sub 2 for depending on how many different premises we have. Right now, we're only looking at 2 premises here, but, obviously we can have more than them. And then using C to represent our conclusion, and then you can actually represent it in this format. So let's take a look at how we can use truth tables to actually help us with analyzing an argument over here. So we've got this statement if he is illiterate, he cannot fill out the application. He can fill out the application, therefore, he is not illiterate. So this is our argument over here. So we've got P defined as he is illiterate, Q defined as he can fill out an application. But when we put this in symbolic form, you can see we are saying if he is illiterate, so that's our P, then he cannot fill out an application, so that's a negation on the Q statement. The second premise is saying he can fill out an application, so that's our Q statement over there. So we are making the conclusion, therefore he is not illiterate, which means a negation on that last part. So you can see how we take our first premise, P implies not Q. We take our second premise and we, kind of in a way attach it by using that and symbol, kind of like how they showed us here in this little box. And then that implies not P. So you are taking the two premises, combining them together by using the and symbol, and then we use the conditional arrow symbol for our conclusion. So it's premise one. In this case, we took our premise one, we are combining it by using the and symbol with our premise two. And then for the conclusion, we use the arrow from our conditional statements. And then you have your conclusion. So that's the setup we will be using when we are using these truth tables to help us come up with a valid argument or not. And then they're just defining those three dots as the therefore symbol. So you can kind of see in this, if he is illiterate, then he cannot fill out an application format. We're creating our truth table. So of course we need the negation column. Then we do the premise one column. We do the premise two column. We are going to use the and state, connective to combine them two. We need to do a negation on the P column, and then we're bringing it all together. So that's kind of how they are combining all of these statements together. Now you will actually see they actually go ahead and copy that not Q column again from here. And the reason for that is so, they don't have to keep going in the wrong direction. And I know, Aaron, we had kind of talked about this initially when we were doing the conditionals, if we need to go from right to left or left to right. So to avoid that circumstance, they're actually just copying the columns again. So that way you don't have to mess around with looking backwards. You can just copy the column and keep looking from left to right. So that's kind of the idea over here. So, they can, you can see they will go ahead, fill out all of those columns. And then finally, in these last two columns, you are using the conditional statement to go forward and see what kind of, final result we are going to have. And I will go through an example with this. I didn't want to spend time on this particular example, but the idea here is if in that final column, which represents this entire statement that we had over here, this is what we have in that final column. If you actually get a truth value in each of your rows, we actually say our argument is valid. So the only way, remember what we said, your conclusion has to be inescapable. For every given instance, for every case, we should know that our conclusion is going to happen. So that's only possible when all of those rows will have a truth value in them. Because if any one of them is false, that means there's at least one instance where our argument is failing, right? Our conclusion is not going to be true. So when that happens, you don't have a valid argument. So for us to have a valid argument in our truth table, that last column, all of our values have to be true for us to say this argument is valid. So let's take a look at an example that I have from our homework over here. Okay, how about Let's start out with something simple right now, and let's look at creating our own symbols so that, once we start looking at truth tables, we know how to combine these together. So let's start with example 4 over here. So they're defining what the P and Q statements are going to be. We're just putting these in the symbolic form. So for this first statement, they have, you do not have financial security if you are a gambler. So if you are defining statement P as you are a gambler and Q as you have financial security, in symbolic form, how would you write this first premise? You do not have financial security if you are a gambler. Okay, so Isabel, you've got not Q implies P. What do you guys think? Do you agree with that? Or do you think it should be a different symbol? Or P implies not Q. So which one are you leaning towards, Isabel? You're going with the second one? Okay. Ethan, you've got not P implies not Q. I don't think we have negation on both of them, do we? Because you do not have financial security is definitely a negation, and that's a negation on, of course, Q statement, so that's not Q. Yeah, Ethan, exactly. And then if you are a gambler, that's of course our P statement. Now remember what I told you, the if goes with the antecedent, so that means P is actually going to be the first part, implies not Q. So yeah, that's what, Isabel, you had for your second one. So again, just because in English the not Q, or in words the not Q is written first, does not mean not Q is going to be our antecedent. It's whatever is part of the if that is always going to be the antecedent. So that's why our P needs to go first, and then the not Q needs to go second. Now, how will you write the second premise? What would you put the second premise in symbolic form?
Can I ask a question real quick? So with the first sentence, since there is an if in there, even though there's not like a then, the implies part still stands, but since there is an if in the sentence, that means that the P and Q, whether it's a negation or not, they're going to be switched, right?
Yeah, so
So,
the if portion always goes first.
okay.
Does that make sense?
Yeah.
Okay, good. Good. Yeah, I'm glad you asked that. So every time you see if, even like you can see in this statement, it's written in the second half of the sentence, the if symbolically will always go first. All right, very nice. So what do you guys think for the premise 2? How would you write that in symbol? You do not have financial security. Very nice. Yeah, because you are just looking at the negation for the not Q. So this is going to be not Q for the second. All right. And then for our conclusion, what would you write that as? Therefore, you are a gambler. Remember, this is our symbol for therefore. Therefore, you are a gambler. Okay, Aaron, you've got Q in there. Ethan P. Yeah, because the you are a gambler is coming from our P statement here, right? So this guy has to be therefore. Okay, good. Therefore, P. So remember again, when you are combining all of these together, you would be writing this as, again, in brackets. We would have parentheses, P implies not Q, close parentheses, and then we would be using the symbol and then we would bring our second statement, which was not Q, close the bracket, then arrow, and then your conclusion, which was P. So this is how you would end up writing it in that final statement form for your argument and your conclusion. Okay, so let me save this, and now let's do an example on, kind of putting this all together. So how about we look at number 14, and this one, as you can see, is asking us to use the example from number 4, but your instructions are use a truth table to determine the validity of the argument specified. If the argument is invalid, then interpret the specific circumstances that are making it into an invalid argument. So let's look at this guy, but we're actually doing example number 4 over here, which was the one we had just talked about. So just to again highlight this very quickly, remember we had this in the form as P implies not Q. We had not Q over here, and then therefore P in this case. So let's go ahead and try and create our truth tables based on this. Let me write this down. And remember, this was number 14. We are defining P as you are a gambler. Defining Q as you have financial security. Okay. So symbolically, this guy here was going to be P implies not Q. This guy here symbolically was just not Q. And then, of course, our conclusion is going to be just P. So when we put all of these together, as I had shown you before, we will have brackets, and then in parentheses, we will do P implies not Q. Then we use our and symbol over here. Okay, to combine our two statements. Then we would have the second premise, which was not Q. Oops. Close your bracket. Then we will have our arrow for the conditional statement, and then our conclusion for P. So basically, this is the argument that we are looking at. We are converting this into symbolic form. So you've got your P implies not Q and not Q, which are the two premises. And then our conclusion was P. So when you are creating your table, of course, we will start out with our P and Q columns. Now let's take it step by step. So you can see for this first statement in our argument where you have P implies not Q, we need to have a negation on Q before we can do that part. So that's the next column we are going to do. Then for our next column, we are actually going to do the P implies not Q. Now, as I was mentioning from the example we looked at from the handout, if your brain works better going from left to right, you can bring the not Q column here again, okay, if you want to. Then, and let me see if I can do this over here. So we've taken care of the not Q. We've taken care of the P implies not Q. We've got the not Q a second time, but now we need to do this whole part that we have inside the brackets. So for the whole part inside the brackets, we need one column for that. So we can go ahead and create a column for what we have inside the brackets. I'm going to put that here. Okay. Again, visually, if it helps you and you want to bring the P column in again on this side, you can do that. But the very last and final column has to be this whole thing put together. Okay, Aaron, you're asking if the truth tables will have 8 rows. And remember, the number of rows is actually based on how many individual statements you have. And in this case, since we only have 2 basic P and Q statements, you will only have 4 rows. So if you had like P, Q, and R, then remember that's when we get into 8 rows. But since we only have P and Q, you will only have 4 rows. So I'm glad you asked that question because yeah, we definitely have to, keep in mind how many rows we will have. So here, since we have only 2 basic statements, that would be 2 to the second power, which will actually give us only 4 rows. So now we can start, filling these in.
So
And go ahead.
so the number of rows in the truth table determines how many statements we have in the problem?
The other way around. The number of statements determines how many rows you will have.
Oh, okay.
Okay. So since it's only 4 rows, that means we can do our true and true, false and false for the P. And then the Q would be, of course, alternating. So true, false, false. And since I actually have a repetition of my P column over here, I'm going to go ahead and fill that out also while I'm here. Now, let's see, somebody who hasn't answered yet. Can you tell me, how about Logan? Logan, I know you try to be a little bit on the quiet side, but go ahead and tell me what the not Q column would look like. Oops. Alrighty, let's take a look. Alrighty, Logan, you've got very nice to change the order of our, that would be false. Oops. Okay, let's try that. For some reason, it's not letting me type. There we go. False, true, false, true. Okay, very nice. Alrighty, so let me see. Kiara, you had the same thing in there, all right. Cole, can you tell us what our next column would look like? Alrighty, so you've got true, true, false, false. That's coming from Cooper. Okay, Cole, what do you think?
I'm just kind of unsure about the last one. I'm saying it's false, so I have true, true, false, false. But would the last, is false correct for the last one?
Okay, so you are looking at, and just give me 1 second over here. So remember, this is P implies Q, which means you're looking at these two columns, right?
Let me make sure. Are you able to like screen mirror again? Like for the, I want to make sure I'm on the right problem.
Okay, so are you wanting to show me your screen?
No, I was just asking what problem. I just want to make sure I'm on the right problem as
Okay,
you.
so we're technically doing number 14, but it's using this problem number 4. So we are talking about, you know, if you are a gambler, you do not have financial security. And if you do not have financial security, does that make you a gambler? And you know, at this point, honestly, it wouldn't matter what our P and Q statements are, since we have already gone ahead and laid out our table. So at this point, you're actually looking at the rules between conditional statements to see, you know, if my first part is the P column and my second part is the not Q column, then under what conditions are they going to be true and under what conditions are they going to be false. So just to show you the conditional statement here again, it really doesn't matter what these headings are, right? Because in our case, we are looking at P and not Q. So what would that mean is, as long as the truth, both of them are true, your conditional statement would be true. If the first one is true, but the second one is false, your conditional is going to be false. And then in the other two cases, it is going to be true. So you're just matching, is my first column true, my second column false, or, you know, what are the values to try and decide. So kind of using that, if this guy here is, come on, buddy. If this guy here is true and this guy is false, what would that value be? Okay, Markley, you've got false for the first one, but then true for all the others. Yeah, because you can see whenever the first or the antecedent is true, but the consequent is false, that's when we have a false statement over here. Now, if this first one is true and the second one is true, then our conditional will be true. If the first one is false and the second one is false, in this case with the conditional, and you can again go back and verify, but when both of them are false, you know, your conditional statement actually is still true. So this would still be true over here. And then with our last case, the first one is false, but the second one is true. That actually also makes it a true statement. So once you set your table out, then you're just using the rules for all the different types of truth tables we have looked at to try and come up with your values over here. Now, again, you will see this is our not Q column, so we can go ahead and copy it over if you like. Let me just get rid of these marks that I had made. So I'm just going to copy my not Q column, which was, of course, your false, true, false, true. That should be a T. Alrighty. So now we are looking at doing a conjunction, because this is the and over here, but you are looking at the and statement over here between this column and this column. So again, remember, this is conjunction. If it helps, go ahead and again open your 1.3 handout so you can see what was that rule for the and that's this one right over here. So the only time a conjunction is true is when both individual statements are true. You can see in all other cases, a conjunction is going to be false. So using this idea, okay, Lisbeth, why don't you tell us what will be the truth values for this column? Okay, so you've got true, false, true, and true. Okay, so again, be careful when you are doing this. The only time your conjunction is going to be true is when both individual statements are true, right? And every time for everything else, it's going to be false. So if you look at our example over here, we've got false and false on both of these, right? It doesn't matter because now we're not going back to the original P and Q statements. We are only looking at these truth values. So since both of them are false, this guy is actually going to be false. Elizabeth, does that make sense? Okay, so look at this next one. Here you can see both of these are true and true. So of course that means this guy will be a truth value. This one here is true and false. So again, they both have to be true for a conjunction to be true. So this guy will be, oops, sorry, that should be false. And then the last one where both of them are true again, that would be true. So both individual statements have to be true for our conjunction to be true. Does everybody see that? Okay. Alrighty, so again, let's get rid of these markings over here. Come on, buddy. Okay, so now that we have done all of these individual parts, now we can go ahead and do our final column. So let's take a look at what that comes out to be. Okay, so for your final column, you will be using, you can see this one here is going to be our P implies not Q and not Q. So that's already this column here that we have completed. And then you are using the P column over here, which we copied back over here. So you are going from left to right in this direction. This is going to be our first column. This is going to be our second column. So again, you are using conditional over here because we are looking at that arrow. So when you are using the conditional, remember you will be using this table. Oh, where are you? This one over here. So again, remember, it has to be true in every instance other than that second case where if you have the first antecedent value as true, but the consequent is false, only then is your conditional statement a false. So if the first one is true, second one is false, our conditional statement is going to be false. But for all other cases, it's going to be true. So using that table, let's see, Macy, can you tell me what our last column would end up looking like? Alrighty. So you've got true, 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 and then false on the last one. All right, let's take a look at that. So this guy here, you've got true on the first one, false on the second one. And like I just showed you, yes, that's the only instance where a conditional statement is going to be false. You have false on the first one. So false on the first one, true on the second one. That is going to be true because even though you didn't meet the condition, you still got the conclusion. So that's true. If both of them are true, then of course our conditional statement is true. So this guy here would be a true value. If both of them are individually false, our claim is still true. So yeah, very nice, Macy. The first 3 rows are going to be true, and then the last one is going to be false. So because we have the false statement in there, Remember, that means this is not a valid argument because there is one condition under which we are not getting a truth value. So since we have this false value in here, this is not a valid argument. And in our instructions, they were actually asking us to identify under what circumstance. So the second part, they said if the if the argument is invalid, interpret the specific circumstances that cause it to be invalid. So in our case, that would be, well, actually, this should be the argument. Because, you know, this is actually invalid. If you look at your original P and Q statements, they were actually both false in this case. So you would say this argument is invalid if you are not a gambler and you do not have financial insecurity, or you're not financially secure. So you do have to identify under what instance would your argument be invalid. And in this case, since both our original P and Q statements are false, that's what you would identify, that the argument is invalid if you are not a gambler and you do not have financial security. So Aaron, the argument would have been valid if all 4 rows in that final column would have been true. So instead of that last one being false, if that one would have been true here, then we could have said we have a valid argument. So all 4 rows in that last column should be true. So if you look at this example we had talked about, you will see how all 4 of our rows had a true value in there, which is what made it a valid argument.
So the argument is only valid if all of the letters in the last row of the truth table is true?
Yes.
That's only valid?
Exactly, yeah. So that last column, every single truth value has to be true for it to be considered a valid argument. And remember, this is basically coming from that same idea of saying that for every instance in every situation, we should get that same conclusion. We should always reach the same conclusion. So if you look at our example over here, for that last one where you're getting the false, we are basically saying, if you go back to our example over here, you know, where we have, oops. So, you know, our original argument over here is talking about how you do not have financial security if you are a gambler. You do not have financial security, therefore, you are a gambler. So we are actually saying in that last case that that conclusion where they're saying you are going to be a gambler is not true, because, you know, obviously you are not a gambler and you don't have financial security. So in this case, you are not going to get the guaranteed conclusion of you being a gambler. So that's where it's failing, basically. So again, we are saying this argument is not going to be true in that instance where the person they are talking about is not a gambler and they don't have financial security. Because, you know, if you think about this example, it's basically saying, if you do not have financial security, so, you know, maybe you don't have a savings account, or maybe you don't have some money invested somewhere. So they're saying basically, if you don't have any kind of financial security, that means you are going to be a gambler. But that's not true in that last case, because we are saying, okay, yeah, we don't have financial security, but we are not a gambler either. So, you know, we're not getting that conclusion that only people who don't have financial security are gamblers is not going to be true. So that's actually what's making this entire argument invalid. Now, if you would have had a true statement on that last one, then we could have actually said this is going to be true no matter what, which is obviously not the case in this example.
Okay.
Does that help?
Yeah.
Okay. Okay. Anybody else question on this one? Okay, I actually wanted to do another example, but that one actually has 3 different rows in it. So, obviously we won't have time to do that today. And I was really hoping to finish chapter 1 today because I wanted us to be able to, move on, take our exam and get into chapter 2. So what we're going to do, guys, is obviously I'm going to have to move my date again. So let's finish 1.5 on, what would that be, Tuesday, since we're only meeting for 1 day this week. So we'll finish 1.5 and I will actually get started with 2.1 in our next class. So we'll finish 1.5, start 2.1, and then we will make the exam date, because we're actually not going to be doing our exams in class, because we do actually have a lot of chapters and sections we need to cover. To save some time, we're actually not going to be doing exams in class. So exams you will be doing outside of class. So I think I'll open the exam for Tuesday and maybe give you guys 24 hours to work on the exam, so that way you can do it anytime between those 24 hours to take your exam. So I think that's kind of what we are looking at with this exam time. So think about it. Let me know what you think about that, and then we'll talk about it on Tuesday. Okay, so all of your homework is open, your quiz is open, your practice exam is open. So please make sure you get that minimum of 90% on each homework section so that you're ready to take your quiz and the chapter exam, okay? So I will open the test on Tuesday, but like I said, it will not be in class, Cooper. I will give you 24 hours. So probably when class ends, which is, 11:40 for us till 11:40 the next morning. So I'll give you 24 hours to work on the exam. Okay, any other questions coming to mind? Okay. All right, guys. So I will see you on Tuesday morning. If you have any questions, definitely let me know. All right, everybody, be careful, stay safe, and I will see you on Tuesday. Bye, guys.
Have a good weekend. Have a good weekend.
Oh, okay. All right. You too. Take care, Aaron. Bye-bye.
Bye.